Now we're going to start to look at some of the properties of exponents. In the last video, we kind of looked at the multiplication rule. In the last video, we actually did a brief example to show exactly where this came from. And while I won't do that for the rest of the rules, it's very simple to just pick some numbers for m and n and see what happens, and you should get that these rules are accurate. So this is our multiplication rule. Next, we'll look at the quotient rule. The quotient rule says if we're dividing two exponents with the same base, we can subtract the exponents, and it'll be the top minus the bottom. Our next rule says that if we want to raise an exponent to another exponent, we multiply. So a to the m raised to the nth power would be a to the mn. Next, raising a product to a power. If we're multiplying two things and we raise the entire product to a power, then we need to raise each individual part to that power. So essentially, if you have a parentheses, raise everything inside that parentheses to that exponent. Along with that, we have quotient to a power. If you raise a fraction to a power, that's the same thing as raising the top to that power and the bottom to that power. My next one starts dealing with negative exponents. Essentially, if I raise a fraction to a negative exponent, it's the same thing as flipping the fraction over and raising it to the positive exponent. So a over b to the negative n is the same thing as b over a to the n. And finally, a to the negative m over b to the negative m is the same thing as b to the m over a to the n. Essentially, what this one says is if you have a negative exponent, take that term and move it to the other side of the fraction to make the exponent positive. So now that we have our rules, let's do a few examples of looking at how these rules work. X to the 5th times x to the 8th. My multiplication rule says that I need to add these exponents. So x to the 8 plus 5, which would be x to the 13. A squared times a to the negative 9. Once again, we would add, so 2 plus negative 9, which is negative 7. Oh, I used an x instead of an a. So I have a to the negative 7, and in general we don't like to keep exponents negative, so we rewrite this as 1 over a to the 7th. Z to the 6 over z squared. I would subtract the exponent since I'm dividing. 6 minus 2 is 4, so this is z to the 4th. G to the 5th raised to the 4th power. Our rule says when we raise an exponent to an exponent, we multiply. And 5 times 4 is 20, so this is g to the 20th power. 5x parentheses cubed. Our rule says we would raise everything inside that parenthesis to the power, so 5 cubed, x cubed. And 5 cubed is 125, x cubed. U over 3 to the 4th power. The rule says we raise the top of the fraction to the 4th power and the bottom of the fraction to the 4th power. So I have u to the 4th over 3 to the 4th, which is 81. Now that we've done a few basic examples to see how these rules work, let's look at some bigger examples where we might have to combine multiple rules in a single problem. Here I have 5a to the 4th b to the 6th times 2a b to the 4th to the 5th power. So we want to start by getting rid of these parentheses. The first one, we don't really do anything, so we can just ignore it. The second one, we do have an exponent outside that parentheses, so we need to raise everything inside to the 5th power. So I have 2 to the 5th, a to the 5th, and b to the 4th to the 5th. And when I raise an exponent to an exponent, I multiply. So that becomes b to the 20th. 2 to the 5th is 32, times 5 is 160. So that deals with my two numbers. Next, I'm going to look at these a's. When I'm multiplying, I add exponents. 4 plus 5 is 9. And finally, the b's. Once again, I'm multiplying, so 20 plus 6 is 26. And the key to these bigger problems is to take them step by step. If you have parentheses, start by getting rid of the parentheses, and then just go numbers, and then letter by letter. My next one, r over s to the 4th times s cubed r over t to the 6th. First, we get rid of the exponent, the parentheses. So for my first one, I can rewrite this as r to the 4 over s to the 4. And for the second one, I need to raise everything inside that parentheses to the 6th power. S cubed to the 6th power, whenever I multiply, or whenever I raise a power to a power, I multiply. I then have an r to the 6th over t to the 6th. When I multiply fractions, I multiply across the top and multiply across the bottom. On the top, I have an S18. In the r's, I need to add 4 plus 6 to get 10. On the bottom, I have s to the 4th, t to the 6th. Finally, I can reduce my s's. Since I'm dividing, I need to subtract, and 18 minus 4 is 14. So I have s to the 14, r to the 10, over t to the 6th. Next, 10x squared y to the minus 6 over 5x to the negative 4 y cubed. Let's start with just the coefficients, the numbers. 10 divided by 5 is 2. When I divide, I need to subtract the exponents. So I have 2 minus negative 4 for the x, and for the y, negative 6 minus 3. 2 minus negative 4 is 6, and negative 6 minus 3 is negative 9. Since we don't like negative exponents, I'm going to rewrite this as 2x to the 6th over y to the 9th. And for our last example, a squared over 7b to the 4th raised to the negative 2. One of our rules says that if we raise a fraction to a negative power, it's the same thing as flipping the fraction over. So this is 7b to the 4th over a squared squared. So I need to make sure everything inside that parentheses is raised to that 2 power. So I have 7 squared. When I raise an exponent to an exponent, I multiply. 4 times 2 is 8, and 2 times 2 is 4. And we know that 7 squared is 49. So 49 b to the 8th over a to the 4th.